Hello, welcome to the Point. This is a fairly new series talking about the human body, amongst other things. We're talking a little bit about botany and zoology, but today we're going to be talking about the human body, but we're going to take a step back and look at human body from instead of getting up close and personal with the human body, we're trying to look at the whole thing as a functioning unit, if you like, and also how the human body, created in the image of God, actually survives on planet Earth, which is also created by God. Before I start, I just want to recommend programs by a very close friend of mine, who you know very well, probably, Dr. Laura Richardson. She actually has a wonderful program, Health in Focus, which is Wednesdays at 3:30. So we try and work together, and we have slightly different emphases. But anyway, I do recommend Laura's programs, Health in Focus, 3:30 every Wednesday. Now, this is going to be a slightly different program. We're going to show you a 9-minute video by a very famous person. I'll read his name out, Professor Alexander Tsiaris, that's spelled Tsiaras, who is an associate professor of medicine at Yale University. He is so clever that, as he will tell you in the video, NASA actually asked him to work for them as well. He'll tell you what he does with NASA. He is incredibly bright, this person. And I thought it was such an amazing video that I would take up 9 minutes of this program to show the video. So what we're going to actually see when we watch this video in just a moment is we're going to see how God actually forms each one of us in our mother's womb. We need to remember, as we look at this, that Jesus Christ is the author of life itself. It says in John chapter 1, "In the beginning was the Word was with God, the Word was God. All things were created by him. Nothing was made without him. In him was life." So where does life come from? Answer from Jesus Christ. All right? Answer from Jesus Christ. And as we look at this amazing miracle in the womb, a baby forming itself over 9 months, what we're seeing is the genetic code, the DNA, causing the baby to grow all those specialized cells, heart cells, lung cells, eye cells, bone cells, skin cells, kidney cells, liver cells, and all the other cells. And we've got 100 trillion of them, by the way, and they're all different, just so that everything works together. Now, when we've seen this program, I'm just going to show you how absolutely extraordinary the whole thing is. So if we can just take 10 minutes, or actually 9 minutes, just to watch this video, and I hope you enjoy it, and I'll see you when we've watched it.
I was offered a position as Associate Professor of Medicine and Chief of Scientific Visualization at Yale University in the Department of Medicine. And my job was to write many of the algorithms and code for NASA to do virtual surgery in preparation for the astronauts going into deep space flight so they could be cut in robotic pods. One of the fascinating things about what we were actually working on is that we were seeing, using the new kind of scanning technologies, things that had never been seen before. I mean, not only in disease management, but also things that allowed us to see things about the body that just made you marvel. I remember one of the first times we were looking at collagen, and your entire body, everything, your hair, skin, bone, nails, everything is made of collagen, and it's a kind of a rope-like structure that twirls and swirls like this, and the only place that collagen changes its structure is in the corner of your eye. In your eye, it becomes a grid formation, and therefore it becomes transparent as opposed to opaque. So perfectly organized a structure, it was hard not to attribute divinity to it, because we kept on seeing this over and over and over again in different parts of the body. One of the opportunities I had was one person was working on a really interesting kind of micromagnetic resonance imaging machine with the NIH, and what we were going to do is scan a new project on the development of the fetus from conception to birth using these kinds of new technologies. So I wrote the algorithms and code, and he built the hardware. Paul Lauterborough then went on to win the Nobel Prize for inventing the MRI. I get the data. And I'm going to show you a sample of that piece from conception to birth. Thank you. But as you can see, when you actually start working on this data, it's pretty spectacular. And as we kept on scanning more and more, working on this project, looking at these two simple cells that had this kind of unbelievable machinery that will become the magic of you. And as we kept on working on this data, looking at small clusters of the body, these little, pieces of tissue that were the trophoblast coming off of the blastocyst, all of a sudden burrowing itself into the side of the uterus, saying, I'm here to stay. All of a sudden having a conversation of communications of the estrogens, the progesterones, saying, I'm here to stay, plant me, building this incredible trilinear fetus that becomes within 44 days something that you can recognize, and then at 9 weeks is really like a kind of a little human being. The marvel of this information, how do we actually have this biological mechanism inside our body to actually see this information? I'm going to show you something pretty unique. Here's a human heart at 25. It's just basically 2 strands. And like this magnificent origami, cells are developing at 1 million cells per second at 4 weeks as it's just folding on itself. Within 5 weeks, you can start to see the early atrium and the early ventricles. 6 weeks, these folds are now beginning with a papilla on the inside of the heart, actually being able to pull down each one of those valves in your heart until you get actually a mature heart, and then basically the development of the entire human body. The magic of the mechanisms inside each genetic structure saying exactly where that nerve cell should go. The complexity of these, the mathematical models on how these things are indeed done are beyond human comprehension. Even though I am a mathematician, I look at this with a marvel of how do these instruction sets not make these mistakes as they build what is us. It's a mystery, it's magic, it's divinity. I mean, then when you start to take a look at an adult life, take a look at this little tuft of capillaries. It's just a tiny substructure, microscopic, but basically by the time you're at 9 months and you've given birth, you have almost 60,000 miles of vessels inside your body. I mean, and only 1 mile is visible, 59,999 miles that are basically bringing nutrients and taking waste away. The complexity of building that within a single system is, again, beyond any comprehension of any existing mathematics today. And then instruction set from the brain to every other part of the body. Look at the complexity of the folding. Where is this intelligence of knowing that a fold can actually hold more information? So as you actually watch the baby's brain grow, and this is one of the things that we're doing right now. We're actually doing a longitudinal studies of actually scanning babies' brains from the moment they're born every 6 months until they're 6 years old. We're going to be doing actually about 250 children, watching exactly how the jirai and the sukai of the brains fold to see how this magnificent develop actually turns into memories and the marvel that is us. And it's not just our own existence, but how does the woman's body understand to have genetic structure that not only builds her own, but then has the understanding that allows her to become a walking immunological cardiovascular system that basically is a mobile system that can actually nurture, treat this child with the kind of marvel that is beyond, again, our comprehension, the magic that is existence, that is us. Thank you.
Welcome back. I hope you enjoyed that. What we're seeing there is actually a miracle. It really is a miracle. And by the way, that happened to you. And it happened to me as well. It happened to all of us. I've actually done 2 programs already on DNA, deoxyribonucleic acid, which is a very complicated genetic code. I'm not going to talk about it now because I've already done 2 programs on it. But it's possible you've actually missed them. If you have, you can go to my website, which is called freechristianteaching.org. And these programs will be on DNA, and the eye and the ear and lots of other pieces will be on the website. You can also order free DVDs as well. But I just wanted to, I'm not going to show a lot of pictures now. I'm simply going to talk to you for the next 15 minutes about just how complicated we structurally are, and how complicated is the environment in which we find ourselves. So I know there's a place in London, I keep going on about this, called the Natural History Museum, but it should be renamed. It should be renamed because there is no natural history. There is nothing natural. It was all created by God. I would call that supernatural, and I hope you agree. The thing is, we are created in the image of God, and you've just seen the miracle of life in the womb. It is a miracle. It's unbelievable. By the way, one of the things you didn't mention is that all of our cells, they grow into eye cells and heart cells and lung cells, but something within those cells, they don't grow anymore. If they did, we'd all have cancer. That's basically what cancer is, cells growing too much. But we won't go down that avenue. So I just thought, well, what do humans actually need for life? Well, actually, there's a huge number of things we need, but here are 7. First of all, we need energy, which in our case, it comes from the sun in the form of heat and light. We need food, and most of the food we eat actually is carbohydrate. Now, I know we get proteins and fats, but we get that from animals and fish mostly, but of course they in turn eat carbohydrate. So basically we must have carbohydrate, okay? We need water, because nearly all our bodies is virtually all water. We need oxygen, because that's how we live. We breathe in oxygen and we breathe out a waste product called carbon dioxide, all right? Then we need various elements, because we're made of 60 elements, but come from the dust of the ground, if you like. We need a design system. Deoxyribonucleic acids is fantastic genetic code in all our 100 trillion cells. If you just got one of those DNA strands and spread it out, it'd be 6 foot long. And there are about 3 billion codes in each individual cell to make sure that it forms itself exactly as you've just been watching. It's not a simple thing. It's really complicated to make a human eye cell or a human brain cell or a human heart cell. That's why I need 3 billion genetic codes per cell, and you've got 100 trillion cells. Right, then what else do you need? Well, you need the design. I've mentioned the design system. Of course, you need the spirit of life too, because basically, James says, the body without the spirit is dead. Now, as a doctor, I was taught that, you know, when somebody's dead, they don't breathe anymore, and you can't feel a pulse, you can't hear a heartbeat. If you do an ECG, it's flat. If you're doing electroencephalogram, it's flat. But actually, what's really happened as well as that is your spirit's left your body. That's what happened to Jesus Christ. It says he gave up his spirit and he died. So for human life, we need all sorts of things. So we're going to look now about how God actually set about providing all these things that we desperately need in order to survive. We need all of them. We can't just have some of them. We need all of them. Right. Well, first of all, we're going to look at energy and light. Now, it comes from the sun. Now, the sun, when you're looking at the sun, what you're actually looking at is a giant nuclear reactor, but a controlled one. It's mostly hydrogen and helium, and it gives off masses and masses and masses and masses and masses of energy, huge amounts of energy. It's 93 million miles away. And it's a very important distance, that, because if we were 5% closer to the sun, all the water in the seas and all the water in our bodies would boil. That's how critical it is. If we were 1% further away, all the water in the sea and all the water in our bodies would freeze into a block of ice. So that's called a parameter. A parameter. We are 93 million miles from the sun, but it can't be too much closer and too much further away. That's very important. Now, look at the sun itself. It's a giant nuclear fission reactor. That's what it is. It's amazingly complicated, but it's also controlled. Now, you're familiar with nuclear bombs. If that giant reactor was not well controlled, it would be a nuclear bomb. Bang. And then there really would be a big bang, like the evolutionists want us to believe in it. No, it's a controlled reaction, but it is an incredibly powerful reaction. Every second, the sun turns over 4 million tons of gas into energy. Every second, it converts over 4 million tons of gas into energy in the form of light and heat. Right. So the amount of energy in the sun is actually far, far greater than if the sun was made of petrol, for example. You know petrol's explosive, but actually petrol, it is very explosive. But weight for weight, the sun is far more powerful of giving off energy than petrol would be. Now we'd look at photosynthesis. You see, we need food and oxygen. Now, if you take an aeroplane, most of you have probably been on an aeroplane, as you look down at the sea and as you look down at the ground, what you're seeing is a massive factory for making food and oxygen. That's what you're looking at. Basically, the sea is full of algae, and the leaves are full of chlorophyll, and the algae are full of chlorophyll as well. And what they do is they take in our waste products, carbon dioxide, they use light from the sun, and using photosynthesis, they make sugars and oxygen. What do we need? Sugars and oxygen. So the sea is our friend. The land, with all the vegetation on it, is our friend. It's not very sensible to keep cutting down the vegetation because they produce what we need. It's an ecosystem. We give off carbon dioxide, which is toxic, but they breathe it in and make it into food and oxygen. Do you think that happened by chance? I don't think so. I don't think it happened by chance at all. What else do we need? Well, just to talk about photosynthesis before we move on, it is incredibly powerful. You may think a leaf is just a leaf, but you get all those leaves and the blades of grass together and all the trees and all the algae and everything else, the rate of energy capture by photosynthesis is immense, approximately 100 terawatts, which is about 6 times larger than the power consumption of all the humans on planet Earth. There's far more energy out there than we can produce or use, far more. And also photosynthesis provides all the carbon which we use in all the cells of our bodies. What else do we need? We'll need water. We're mostly made of water and we need fresh water. Is it by chance it rains? In England it rains quite a lot, you probably noticed, but actually we've got a bit of a drought going on now. But we need lots of water for a whole lot of reasons. All the reactions that happen in our cells, all the biochemistry, all of them require water. Everything is dissolved in water. Our oxygen, all our hormones, everything is dissolved in water. It's a solvent, in other words. We desperately need water. If you go without water for more than a day, you're not going to feel very well. We desperately need water. What about the temperature? Well, look, your temperature is very, very narrowly it has a very narrow distribution. They've changed things now, but when I was a doctor, it was a normal body temperature was 98.4. If you go down below 97 or above 99 Fahrenheit, the enzymes in your body stop working properly. That's why it's very dangerous to have a very high temperature, because the enzymes just don't work properly. A very high temperature and you'll be dead of hypothermia. A very low temperature and you'll be dead. The Titanic's very much in the news at the moment because we've just celebrated the 100th anniversary of the sinking of the Titanic. Let me tell you that people who fell into freezing water at minus 1 or 2 degrees centigrade would be dead almost within a minute, simply because their bodies simply stop functioning. We need all the right gases. Mostly our atmosphere is oxygen and carbon dioxide and nitrogen. We need them in the right amount, the right proportion. We need the leaves to take the carbon dioxide away, which is toxic for us. But there are all sorts of other parameters. For example, the temperature, the ambient temperature. I know we complain that the temperature goes up and down, but actually it doesn't go up and down very much, not compared with outer space. It has to have the right magnetic field. If we didn't have the magnetic field, actually deflects some of this harmful radiation from outer space. It's got to have the right partial pressure of all the gases. The rotation period of the Earth. If it was going too fast, we'd all spin off into outer space. If it's going too slow, the gravity would be so great we wouldn't be able to stand up on our legs. All the gravitational forces in the universe have got to be just right. For example, the moon causes the tides. If the moon was a little bit too close, the tides would be 2 miles high, we'd all be drowned twice a day. If the moon was too far away, we wouldn't have tides at all, and that actually matters The tides do matter for the oxygen and all sorts of other things that go on in the sea. The water vapor saturation is actually very important for us. We can't live in a very water-saturated environment. We can't live in a very dry environment. It's actually very, very critical. The availability of natural resources. We're familiar with wood and coal and all these things, but they're there. We can't do without them. They're there. We need steel. We need all sorts of things. They're there for us to use. And the sunlight provides photosynthesis. The body, I'm going to be spending a whole series of programs talking about the body. The body is incredibly carefully and miraculously and supernaturally designed. You're familiar with the various systems. I'm just going to mention a few of them. Our skeleton, which is basically a crane held up by muscles. Our muscular system, our nervous system, which is a giant computer. You're listening to me now, you're not concentrating on the fact that you're breathing and you're digesting your food, but your brain is doing all that for you. Your respiratory system, your cardiovascular system, your lymphatic system, your endocrine system, your reproductive system, your liver, all sorts of other things, our digestive system, a urinary system, and the homeostasis, that's the regulation of the environment, and also other things like, if you cut yourself, it stops bleeding. There's an awful lot going on. This is the most incredibly complicated thing. Our body is the most sophisticated piece of machinery you can possibly imagine. You can't imagine how complicated our body is. You can't imagine how complicated our brain is. Our brain is a supercomputer. The supercomputers in NASA have got nothing on our brains. I'll be talking about brains just in one program, just talking about the human brain. It's a supercomputer. You know, the way our body functions is amazing. If you've got any feedback, we'd love to hear from you. info@revelationtv.com. Please write to us. We'd love to hear if you think I'm going too fast or other subjects you'd like me to cover. info@revelationtv.com. Please write in and tell us if you think these are helpful and if you'd like me to talk about other subjects or go more slowly, or show more pictures, or less pictures, or whatever it is you want. But whatever it is, what we want you to do is to see things as we see them, to the point. In other words, that you are created in the image of God, and you are actually a miracle in itself. You don't have to wait till you've seen a miracle. You are a miracle, and so am I. God bless you. Thanks for joining us, and join us again soon on To the Point. Thank you.